Find the sum of the series to n terms. 1 cube over 1 plus 1 cube plus 2 cube over 1 plus 3 plus 1 cube plus 2 cube plus 3 cube over 1 plus 3 plus 5 and so on up to n terms. If we find the rth term of this series, it will be 1 cube plus 2 cube plus 3 cube and so on up to r cube over 1 plus 3 plus 5 plus so on up to 2r minus 1. Here, the numerator is in the form of sum of cubes of r natural numbers. By applying the formula for that, we get r square, r plus 1 whole square over 4. And the denominator is in the form of NAP, whose first term is 1, the last term is 2r minus 1, and the common difference is 2. So we can find the sum of these terms. So r over 2 times first term plus the last term. And if you simplify this, you get r square times r plus 1 whole square over 4 divided by the denominator. 1 will cancel out, this 2 will cancel out, we will have only r square. So you can cancel out r square. So you're left with r plus 1 whole square over 4. So rth term of the given series is r plus 1 whole square over 4. To find the sum of the series, we can take summation of this term. So taking summation r equals 1 to n of tr will give us the sum of the series. And on the right hand side, we can write summation r equals 1 to n r plus 1 whole square over 4. 4 is a constant, so we can take it out. So it will be 1 over 4 times summation of r plus 1 whole square. So 1 over 4, if you replace r with 1, we get 2 square, plus if you replace r with 2, we get 3 square, and so on up to n plus 1 whole square. In order to use the formula sum of squares of first n plus 1 natural numbers, what we can do is add and subtract 1 square. So if I add 1 square here and subtract 1 square, for the first n plus 1 terms, we can apply the formula and 1 square will be as it is. So it is the sum is equal to 1 over 4 times sum of squares of first n plus 1 natural numbers, which will be n plus 1, n plus 2, 2 times n plus 1 over 6 minus 1. Simplifying this, we'll get n times 2n squared plus 9n plus 13 over 24.